We're going to work on an ALEKS problem that deals with diluting a strong acid solution to a given pH. In this example, a chemist must prepare 300 milliliters of hydrobromic acid solution with a pH of 1.50 at 25 degrees Celsius. He will do this in 3 steps. He will fill a 300 milliliter volumetric flask about halfway with distilled water. He will measure out a small volume of concentrated 5 molar stock hydrobromic acid solution and add it to the flask. He will fill the flask to the mark with distilled water. We're asked to calculate the volume of concentrated hydrobromic acid that the chemist must measure out in the second step and to round our final answer to 2 significant figures. So the first thing I want to do is come up with a balanced chemical equation. So when I dissolve HBr in water, I get H3O plus and Br minus. In this problem, we're asked to make a new solution that has a pH of 1.5 from a stock solution that has a concentration of 5.0 molar. Now, HBr is a strong acid, so strong acids will ionize completely. So what that really means is that the initial concentration of HBr will actually equal to the initial concentration of H3O plus. So let's write all that down in a given table. Our initial concentration is 5.0. We're asked to determine how much of this initial concentration do we need to make a new solution that has a pH of 1.50, and we're going to need 300 milliliters of this new solution. I'm going to go ahead and convert that to liters. When we're dealing with pH, we can also determine the concentration. Remember that pH is equal to the negative log of the concentration of H3O plus. I have the pH. I can solve for H3O plus, which equals to 10 to the power of negative 1.5. All right, so I just figured out the new concentration of this new solution. So I'm going to go ahead and put that into my given table. All right, so I have the molarity and the volume of my new concentration, or my new solution, and I need to determine the volume of my original solution. So that is the dilution formula. M1 times V1 equals M2 times V2. I'm going to plug in what I do know. So I'm going to solve for V1. But I want my final answer 2 significant figures, and I want it in milliliters. So V1 equals 1.9 milliliters. Let's take a look at another example. In this example, a chemist must prepare 550 milliliters of hydrochloric acid solution with a pH of 1.0 at 25 degrees Celsius. He will do this in 3 steps. He will fill a 550 milliliter volumetric flask about halfway with distilled water. He will measure out a small volume of concentrated 8 molar stock hydrochloric acid solution and add it to the flask. He will then fill the flask to the mark with distilled water. We're asked to calculate the volume of concentrated hydrochloric acid that the chemist must measure out in the second step and round our final answers to 2 significant figures. The first thing I want to do is come up with a balanced chemical equation. So when I dissolve hydrochloric acid in water, I'm going to get H3O plus and Cl minus. So we're asked to figure out the volume of hydrochloric acid to make a new solution that has a pH of 1.0. So HCl is a strong acid, and strong acids ionize completely. So the initial concentration of HCl will equal to the initial concentration of H3O+. And let's show that in a given table. So initially, my concentration is 8.0. I need to figure out the volume of this initial concentration to make a new solution that has a pH of 1.0. And I'm going to have 550 milliliters of this new solution. I'm going to go ahead and convert my milliliters to liters. pH is equal to the negative log of H3O+. I can rearrange the pH formula to get the concentration of H3O+, which is 10 to the negative power of the pH. So my concentration of this new solution is 0.07943. I can come back to my given table and list this new concentration. So I need to make a new solution that has a certain concentration and a certain volume from my initial solution. So that is just the dilution formula. M1 times V1 equals M2 times V2. I'm going to plug in my numbers. And this will give me an answer in liters. But our final answer needs to have two significant figures and in milliliters. So my V1 is 5.5 milliliters. Good luck and keep practicing.